So now that we've learned about saline sodic, and of course normal soils, let's do two sets of calculations. And this first calculation is based on exchangeable sodium. And let's classify this soil. So you're given some information. For example, the cation exchange capacity is 25 milliequivalents per 100 grams. The exchangeable sodium concentration is 1,150 parts per million, or that's the same as milligrams per kilogram. You know that the atomic weight of sodium is 23. It's a given. Somebody measured the electrical conductivity of a saturated paste and it came out at 7 millimoles per centimeter and the pH is 8.2. What's the classification of this soil? So based on the data that you're given, you can get close, but you can't get all the way. So electrical conductivity of 7, greater than 4, it's going to be either saline or saline sodic, right? But which one is it? We need to determine the ESP, or exchangeable sodium percentage, based on this value of 1,150 parts per million exchangeable sodium. And remember the shortcut, right? So here's the shortcut that you learned in the cation exchange capacity unit and that I gave you in several videos ago. You take the concentration of, in this case, sodium in milligrams per kilogram, or parts per million, and you multiply it by the atomic weight. You multiply it by the valence, which is 1, divided by the atomic weight. You do everything inside the bracket first, and then you take that value and divide by 10. And if you did that, you end up with 5, right? That's the amount of sodium. Now to calculate the exchangeable sodium percentage, or the 5, I should mention the 5 is in millimoles per centimeter. Wow, I'm losing it. I'm really losing it. When you do the math, and you should probably use the units because I didn't, and now I forgot the units. But if you use the units in this equation, you would realize that 5 is in milliequivalents per 100 grams. That's what this 10 is for, to convert all this to milliequivalents per 100 grams. To determine exchangeable sodium percentage, it's simply the amount of sodium in milliequivalents per 100 grams, which is 5, divided by the CEC, which is given, it's 25 milliequivalents per 100 grams, and you multiply by 100 to convert to a percentage basis, which equals 20. So the ESP is 20. So we go to this column. We know the electrical conductivity is greater than 4, the ESP is greater than 15, and the pH is less than 8.5, and this is a saline sodic soil, right? And this is important if you ever run into these, because if you know the classification, then you will know how to hopefully solve this problem. Let's do the calculation another way. Instead of using exchangeable sodium, or ESP, let's do the calculation using or determining SAR, right? So we have the same soil. CEC is the same. The electrical conductivity is the same. The pH is the same. But in this case, the saturated paste extract contained 20 milliequivalents of calcium per liter, 10 milliequivalents of magnesium per liter, and 60 milliequivalents of sodium per liter. And I gave you these concentrations on purpose, but you could calculate these if you were given the milligrams per liter instead of milliequivalents per liter. And it's simply based on the valence as compared to the atomic weight, and then divide by 10, right? So it's basically the same as what you had just seen on the previous slide. But I gave you the units that are to be used in the equation for SAR. So here's the equation for SAR. Sodium adsorption ratio equals the sodium concentration divided by everything underneath is under the square root sign. It should say calcium plus magnesium. You add those two together, divide that value by 2, and then take the square root of that value. So if we did that, and I wrote it out here, you put 60 in the numerator, and then you divide by square root of all of this, 20 plus 10, so 20 milliequivalents of calcium plus 10 milliequivalents of magnesium divided by 2 and the square root of that value, and it equals 15.5. So let's go to the table. The electrical conductivity is 7. It's greater than 4, it's saline, or it's saline sodic. The pH is 8.2. It's either saline or saline sodic. The SAR is 15.5. This soil is a saline sodic soil. And again, you can use the classification to determine how to overcome or reduce these issues in the environment, which is what we'll learn in a subsequent video.